Alright, so let's look at this first one. Remember our toolkit strategies. First thing for a limit, we always do direct what? Substitution. Can you do that on number 3? No. Yes. Move. What, Scotty? Which one?
It hit 0 in the denominator.
On number 3, buddy?
That's, oh, my bad. I was looking at the third.
Oh, gotcha. Gotcha. So you can do direct substitution there and get an answer. On number 4, what's your automatic answer, number 4? 8. Now, on number 5, I do direct substitution. I plug 3 in. I get what in the denominator? 0. So I would have to do what here? Rationalize the what? And I would multiply the numerator and denominator by the square root of x plus 1 what? Plus 2. Okay? And you can do that later. Number 8. If I input 0 there, I get what in the denominator? 0. So I'm going to have to find a common denominator on it. Okay? Number 9. Can you directly input pi into x? Yeah, can you tell me the cosine of 3 pi? Yes, that is -1. Number 10. The first thing you do is input what? -3. If I input -3 in that denominator, that gives me 9 plus -15, which is -6 plus 6, which gives me 0. I need to factor that, don't I? Okay. Number 11, I directly input -1 here. -1 squared is 1, plus -5 is -4, plus 4, okay? So I would need to factor that. That's going to be x plus 4, x minus 4, all over x plus 4, x plus 1.
Teachers, please excuse the interruption, but I just want to remind everyone again of what was announced this morning. There is going to be a lifeline helicopter visiting our campus probably within the next 20 to 30 minutes or sooner. And we just want everyone to know there's no emergency. This is part of our health science program. It's some training for our students, learning all they can to make their futures better. Thank you.
All right. Now, guys, look here. On this one, once I input -1 after I did some toolkit strategy, I still get 0 in the denominator, don't I? So this is one side. I go to the left of -1, which is what? -2, isn't it? Okay. Now, since I'm doing this final thing, you know this is going to deal with an asymptote, isn't it? Going to infinity or negative infinity. So I plug -2 in. -2 minus 4 is -6. -2 plus 1 is -1. That gives me a positive. So my answer would be infinity there. Infinity. Alright. On this one, I'm going to plug 4 in. I get 0 in the denominator. So I'm going to factor it. Once I factor that and cancel this out, then I try direct substitution again. I plug 4 into what's there. I don't get 0 in the denominator anymore, so I can do direct substitution. 4 plus 5 is 9. 4 plus 4 is 8, so my answer is 9/8. Number 13, apply direct substitution. I plug 3 in. 3 minus 1 gives me 2 in the denominator, so that means I'm okay. So I'm going to plug 3 in. 3 plus 2 is 5. 5 over 2 is my answer. 5/2. Yes, buddy? Sure. On number 14, I plug -2 in. -2 plus 2 gives me 0. Alright, I can't do any of my strategies here. So is this a one-sided or two-sided? One or two-sided? 2. Isn't it two-sided? Does everybody see that? So that means I'm going to pick a number to the left and to the right. I'm going to plug -3 in. -3 plus 2 gives me -1 squared. That gives me -1 over 1, which is negative. That's going to be negative infinity. I plug -1 in. That gives me a negative value. They both go into negative infinity. Alright, number 15. I plug 3 in. I get 0 in the denominator. Can't have that. I can't do any of my toolkit strategies. So I'm going to pick a number to the left of 3, which is 2. 2 minus 3 is -1. So negative 1 divided by negative 1 gives you a positive. So that means positive infinity. Alright, now, 16 through 24, we're approaching infinity and negative infinity. So, we got to think of it differently. Because you can't do direct substitution on any of those, can you? Can you? So, number 24, this is rational. Remember, when you have rational, what's my what's my highest degree in my numerator? 1. N to the first. My highest degree down there is N to the first. So, what do you do with your leading coefficients? Divide them. 2/4 equals 1/2. All right. What's your highest degree in number 17? What's the highest degree?
3 into the third.
We got what in the numerator? Where you go? Where you go? Oh, okay.
I have to because
I just said okay. I thought we were going to get an all call or something. What are you doing?
Yeah, what's up? Yeah. No, that's not hard. I'm going to be coming out there out there.
Okay, good. Okay.
Are you gonna keep it?
No, you take it.
Okay. The light. Pyramid light.
Bye, Grace. See you Tuesday.
No, that wasn't the thought that told me. Something's up. What?
Are we back okay?
See you Tuesday.
Why should you?
Huh?
Why should you go to the helicopter?
I have to see the helicopter.
If you went on your phone, you would have heard that while ago. All right. Now, this is rational. What's the degree in the numerator? 2. What's the degree in the denominator? 3. Okay. Let's see if you remember this. If the degree is higher in the denominator, what is it? 0. Yep. Wait, let's look at that to make sure. Was that correct? I always forget that rule. Let's look at it. Huh?
Plug in 100 and it's going to come up.
Yes, okay, gotcha.
And then if it's the same,
Okay. All right, number 18. The numerator is higher. The degree in the numerator is higher, isn't it? Okay, it's going to what infinity? So if it's going to positive infinity, let's just plug 100 in. What are you going to get? Positive infinity. Okay, when you have polynomials like 19 through 24, you need to do what with them? Sketch the end behavior, don't you? So I need you to do that right now for those 5. This one right here, if I was to draw this, it'd be something like that, wouldn't it? Because you've got an odd power, and it's positive, so you go increase from left to right. Do y'all see that? As n goes to infinity, where's my n going to? Where's my n going to? Positive infinity. Y'all understand that? N cubed. Okay? Is something like this. As I go to negative infinity, my n goes where? Negative infinity. Number 21. My highest degree is a square. It's quadratic. Leading coefficient positive, so it's going to be pointing upward. As n goes to negative infinity, that goes to positive infinity. Alright. Notice here, it is even. But what do you notice about the leading coefficients? What? So it would be pointing upward or downward? Downward. So as x goes to infinity, it goes to negative infinity. Number 23. Notice that this is odd and the leading coefficient is negative. So instead of increasing, it's going to be something like this. Okay, because it's negative leading coefficient. As n goes to infinity, this is going to negative infinity. And same thing for this as well. This is, your highest degree is 3, leading coefficient is negative. You've been gone a long time. Well, you going to get, oh. Now, it would be going to positive infinity. Positive infinity. Alright, which of these derivatives do you want me to do? I won't get all of them done today. Which ones? 32. 32. Let's look at good old 32. Here we go. First thing I need to do is write. What do I need to do right here? I need to rewrite. I need to rewrite it. We need to rewrite that. First of all, the radicals catch my eye. The square root of x, I know I'm dealing with 1/2. Here I put negative 1/2 because that radical is in the denominator. Square root of x, I rewrite that as x. 1/2. Okay, now I'm ready to find my derivative. Negative 1/2 times 2. Now, first of all, are there any questions how I rewrote that? Posky, you good?
Yes.
Alright, here we go. Negative 1/2 times 2 is negative 1. Negative 1/2 minus 1 is negative 3/2. 1/2 times 1/2 is 1/4. 1/2 minus 1 is negative 1/2. Now I write my final answer. F prime. Okay. That's the root. That's the exponent. Make sure you understand. There's a negative 1. I leave it in the numerator. Put that's part in the denominator because it's a negative exponent. Plus, I'm going to put that in the denominator, square root of x. Okay, what's another one down there? All of them. 28. That's a good one if you want me to do 28. Which one, Parker? You just want me to start from the beginning. Okay, here we go. 25. 25. What you say? I'm gonna get to it, buddy. I'm gonna get to it. I'm not gonna give you one like 31 anyway. Okay. 3 times 4 is 12. 3 minus 1 is 2. 2 times negative 3 is negative 6. X. First of all, there was no need to rewrite because I didn't have any radicals or negative exponents, okay? 1 times 2 is 2. 1 minus 1 is 0. And then pi is just a constant. So there's your derivative. Number 26. This right here makes me want to rewrite it. I need to rewrite number 26. F of x equals x squared over 3 minus 3x squared. And I have a fraction here. I need to rewrite that as well. That equals 1/3 x squared. I did not make that a negative 2 because that was not in the denominator. Minus 3. Now this is moving up, so that does become a negative 2 there. Two times 1/3 is 2/3. 2 minus 1 is 1. Negative 2 times negative 3 is positive 6. Negative 2 minus 1 is negative 3. F prime, my final answer is 2/3 x. Now that's a negative, so I'm going to put that in the denominator. You want to go get them? Put my calculator up. Or, yeah, you can put your calculator and just take your stuff. Alright. Number 27. What do you think we need to do on 27 first off? Multiply by what? Negative 3. So I'm going to do that above that. That's going to be negative 6x squared plus 15x minus 3. Now I'm going to find f prime of that. 2 times negative 6 is negative 12. 2 minus 1 is 1. Derivative of 15x is 15. Is that your charger? Okay. That's 15. And derivative of negative 3 is 0. You don't have to worry about that one. Alright, number 28. I'm going to skip to 29 for a moment. F of x equals x plus 1 over 2. So, Mr. Chester, what would you do there? What I would do there, guys, is rewrite that to mean 1/2 x plus 1/2. I just split it up and gave each of them that 2 in the denominator. That means the same thing. Now, the derivative of that would be 1/2, and then that is 0, so it's just 1/2 is your derivative. Does that make sense? Alright. Number 30. F of x equals x squared minus 2. I would split it up and simplify before I start. Have a great day. Monday, Ms. Clemens will be in here with you. Tuesday, seniors, your final. Juniors, I'll work with you more on derivatives then. Okay?